Welcome to Chapter 4 class. Now, Chapter 4 is all about quadratic functions and equations. Now, by quadratic, what I mean is a polynomial with degree of 2. Now, you can see this first section of notes right here. This is showing you the parent function, the most basic quadratic, y equals x squared. Something you may remember, the vertex, which is indicated right here. The vertex represents the highest or the lowest point. And through that vertex is your axis of symmetry represented by that red line. Because parabolas, you're always getting a mirror image of the two sides. Now, for the intents and purposes of this video, we're going to basically begin with the vocabulary, learning all of the vocabulary that you're going to have to know throughout this chapter. Now, the first thing we're going to discuss is the vertex form of a quadratic. So, vertex form, when you're looking at it, should kind of make you think of the transformation sections we did back in Chapter 2. Because essentially, there's 3 pieces to the vertex form of a quadratic. There's this A value. That A value is creating your vertical stretch or compression. If the A value is a number greater than 1, it's stretching it. If it's between 0 and 1, it's compressing it. This piece here with the X, that is your horizontal translation piece. It's moving it left and right. Now remember, this is a piece, it's opposite of what you'd expect. When you see a minus there, it's actually moving it to the right. A positive there is moving it to the left. And then this number out here, that is your vertical translation. That is moving your function up and down. Now the reason that this is called vertex form is because your vertex ends up being the point HK. So that's why it gets this name. But really all you have to think of this as is a set of transformations from the parent function y equals x squared. Now, if you look through the rest of this page, this is just 2 little tables to remind you of those things. But really the basis of what you need is sitting right here, okay, in the vertex form, because we need to recall what those transformations look like. So let's take 2 examples really quickly to recall those transformations. So I'm going to begin working left to right, just like I'm reading a book. So the first thing I notice is that 2. Now remember, whatever is multiplying the x term, that becomes a vertical stretch. So we have a vertical stretch of 2. Right? That's always the multiplier, is the vertical stretch. Next, we have the number that's shifting the x. And again, shifting the x means a horizontal translation. And recall, please, that a positive number there means it's actually shifting to the left. It's going to the left 5. And then finally, that minus 3 at the end, that is your vertical translation, your up and down translation. And the negative there means exactly what you think it would, down 3. All right, and our next example, pretty much the same thing, just showing you what happens with the opposite signs. So here that 3, again, that multiplier is always your vertical stretch of 3. This time the number that's shifting the x, your horizontal translation, that is a negative number. So remember, a negative number there means it is going to the right 4. And lastly, that plus 2, that is your vertical translation And it works exactly as you think about a positive there means you're going up 2. So all we have to do is think of this in terms of transformations. Now, that's only the beginning, the surface of the vocabulary that you're going to have to know. So I'm going to start with one example, and we're going to step through this whole thing discussing that particular vocabulary. So, first thing, transformations. Now, I'd like you to notice when there is a negative with your vertical stretch, that negative means the first thing you have is an x-axis reflection. What that means is your parabola is being faced downward. So that's the very first thing that you're going to note. It has an x-axis reflection, and that also means a vertical stretch of 2. You get both of those things from that first number. And again, all that negative means is that x-axis reflection is being flipped down. Now, let's get the other two pieces. That +3, that's your horizontal translation. And remember, the horizontal piece works opposite what you'd expect. So horizontal translation, left 3. Then that -5 is your vertical translation. Down 3. That one acts just like you would expect. So, there are all of our transformations. Now, the vertex, that's going to be another thing I ask you to identify. So the vertex, it is a maximum or minimum point of a parabola. In vertex form, it is a point HK, or the way I think of it as following those translations. Because your basic parabola will start with it at the origin. However, when you're transforming it, your horizontal translation is left 3. That left 3 will put its x value at -3. Vertical translation, if it's moving down, oh, I'm sorry, that is down 5, not 3. If it's being shifted down 5, its vertex goes down 5. So consider the vertex shifting with those translations. That's going to be the easiest way to think of it. So left is going to make it negative. Down is also going to make the y negative. Maximum or minimum value. It's a maximum when a is greater than 0, so it opens down. Minimum when a is greater than 0 or opens up. So this one, a is less than 0. Less than 0 means it's going to be arcing like that. So our vertex, when that a is negative, it's making it face downward. It is going to make the vertex a maximum value. So for that question, when you're asked max or min, all you have to do is choose one, and it's based on the a value, depending on if it's opening up or down, because that'll make it a max or a min. Axis of symmetry. So for the axis of symmetry, this is really easy. There's no new work that you have to do because it is exactly the same as the x value of the vertex. So we represent it as the line x equals h being the x value from the vertex. So in this case, if you go back and notice, the x value in our vertex was -3. So all I have to do is state x equals -3. It's where my axis of symmetry is. Just use that same value. That's all you have to do. All right, continuing on. So we're going to continue on to our next page. Domain. Domain represents the x values that can be used in a function. For parabolas, the domain is always all real numbers, okay? You can always use any x value in a parabola. So domain is always the easy one. All you have to put is all real numbers. The range. The range is where it gets a little bit more interesting, okay? So we've already decided our parabola is facing downward. We found there's a vertex at -3, -5. So that range, okay, the range is based on that y value, that -5. Now, in this case, that -5 is going to represent the highest point of that graph, okay, the highest y value possible. So what that range is telling us is every other y value has to be less than or equal to that -5, right? Because the range is connected to y values. Now, I put it in some technical language here for you. The vertex is a minimum. The range is always y is greater than or equal to the y value of the vertex. If the vertex is a maximum, the range is y is always less than or equal to that y value of the vertex. But again, if you just kind of make a mental image of it, you should be able to sort through it. So that is all the vocabulary working through a single problem. So what I'm going to do now, I'm going to go through one more problem with you, getting all the vocabulary just like you'll see in your practice work, just like you'll see on your test. So here's a function we're starting with this time, and it wants us to describe the transformations. So starting with f5, that multiplier is positive and it is greater than 1. So what that means is we have a vertical stretch of 5. Our x is being shifted, so we have a horizontal shift, horizontal translation. Remember, a negative there means to the right, so to the right 4. And then we have that plus 6. So that is going to be our vertical translation up 6. That one acts the way that we'd expect. So when it comes to the vertex, remember the vertex shifts the same way as the rest of the transformations. So the vertex is going to the right 4 and up 6. So the vertex comes directly from those transformations. And as for the axis of symmetry, well, the axis of symmetry, you just take that x value, so that 4 that you found, and just state x equals 4. Max or min. So what I'd like you to picture is the A is positive, so it's opening upward. So we have our vertex down here chilling at 4, 6. That's kind of a little mental image. So seeing that makes it clear that vertex is a minimum value. As we move on to answer our last two questions, domain. Remember, domain is the easier of the two. Domain is always all real numbers. You can use any x value with parabolas. In terms of the range, remember the range is determined by that vertex. So notice, the vertex is a minimum. So that means it is the smallest y. So every y that you're going to see is going to be greater than or equal to the y value of that vertex, which in this case is that 6. All right. So I thank you for joining me for these notes. Please make sure you have all of this written down and then come back to class prepared for us to do our practice work.